watch it for you. Oh my gosh, this kid needs to think about it.
Rain is
But
not.
it's your choice. You're the kid. Put some soap on the car and let the rain just wash it.
And let the rain wash it off. Yeah, that would work.
No.
So, how did anybody like do this and kind of explain how you thought about it as you were solving the problem, Virginia?
I just kind of went through the days and tried to put things like how many different things you could do. Like on the first 6 days or 4.
So in the first day, she said you can do one of 4 chores because Thursday and Friday, that's the day you have to wash the car. One of those 2 days. So that takes that option out when you're solving the problem. So you can't wash the car on Monday. That means you have 4 options. You can clean your room, you can cut the grass, you can clean the garage, you can shine your shoes. So you have 4 choices to choose from when you're dealing with your chores, completing them on Monday. And then on Tuesday, Virginia, you would have 3 because you're not going to do the same chore twice. You're just doing that once. And then on Wednesday, you have 2 left. So say you cut the grass on Monday, you washed your car, you cleaned your room on Tuesday. So now on Wednesday, you have to clean the garage or shine your shoes. On Thursday, how many chores do you still have remaining? 2. Because you have the chore that you didn't do on Monday, Tuesday, and Wednesday, and you also have to wash the car. So that 2 is here for Thursday, and then on Friday, you only have 1 chore left. Whether it's washing the car or doing one of the other 4 that you didn't do earlier in the week. So when you multiply all those together, 3 times 4 is 12. 2 times 2 is 4. 12 times 4 makes 48. So there are 48 different orders or different ways that you could perform those 5 chores, specifically saying that you have to wash the car one of those last 2 days.
I did it differently, but got the right answer, but I'm not sure that it would work if there was another problem like this.
If it wasn't a problem like this, what did you do?
I did, so I had like on Monday, like, I don't know how to explain this to you. You might just have to come look at Monday.
Okay. Are there any other questions?
Literally just whether you wash your car and then you get someone
Yeah.
the next day. If you look outside, you look like a really nice house, but we're all sitting now. I'm cold and I left the house. It's 78 on Friday.
So any other questions? Please, for tonight's homework, for tomorrow's homework, you need to have some kind of work. Like, having a random answer shows me no way of how you're getting that random answer. You gotta have something. Like, when you're doing the license plate problem, you should have had all the numbers that you're multiplying together, not just a huge answer that popped out of the air. Now, the middle problems, like, no, 9 through 24, you don't have to show work for those. You're just plugging that in your calculator. But 25, you should show me what you're using to get that answer. There are 4 letters. None of them are repeated, so it's just 4 factorial. But please show work. That's just because we're doing probability doesn't mean that that part can just not be done.
I wrote that. I just wrote 4 factorial. Is that showing?
That's still showing work. Yep. But I should see something as to how you're getting those numbers, even if it's just multiplying numbers together. So today we are going to talk about combinations, which would be kind of the opposite of a permutation. Permutation order is important. Combination are just taking groups or pairs of things, not really ordering them like first, second, third, fourth, fifth plates. In your packet, you'll take out section 10.2. There are 5 little warm-up problems. See if you can quickly go through those warm-up problems. The first 4 is using your calculator, just working with the factorial button. Number 5 is a tiny little word problem.
No, I feel like probably Yeah. Good extension.
At dance class last night, I was able to almost get a whole class set of tests graded. So what I didn't get graded, I graded later on in the night. So last night I got another set done. I have 1.5 left.
Look at you go,
I
Miss
know,
Payne.
right? And I was talking while I was grading. So whose class was it grade? Oh, class 6.
Probably almost like.
6th period. So 6th period might have done really well because I was talking while grading.
Could you go back and talk and
Yeah.
Anyone lucky enough to go to the Kings game tonight? No. How about any playoff games? Anybody have playoff tickets? Mr. Kane said he's gonna look at stuff up today and skip out on the baton performance tonight. I was like, I don't think that's allowed.
What's your daughter's name? Samantha? I know it's
Sadie. He missed out on her dance recital last year because he had to be at Cedar Point.
He had to be at Cedar Point.
He had to.
Why
be
do you
there.
I wish I could just have.
He's in charge because he's in charge of that. Like he
Oh.
organizes the whole thing.
Telling the senior.
Man, I wish I
Yes,
could have
that's
that
the
job.
senior trip. Yeah.
I think our senior trip should be something different.
All right. 5 factorial is 120. 4 minus 2
Wow.
would be 2 factorial times 3 factorial, or
It's 12.
12. 8 factorial divided by 5 factorial is,
36.
and then 7 permutation 5. So we have 7. We're ordering them into 5 different ways. 2,520. I heard. Thank you. I heard 2,500 something. All right, and then the last one. You have 6 people that are in line to buy tickets for movies. How many different ways can those 6 people line up to buy a ticket? Just stand in line. So
Order.
it doesn't matter. David, what'd you say? Why 720? Yeah, it's 6 factorial. So you have 6 people to be first in line, and then 5 to be second, 4 to be third, and so on. So 6 factorial is 720. So today we're going to talk about the combinations, and you'll see how they do change a little bit compared to permutation. So a combination is a group of objects, and you will see the word group or the word pair in the word problems that you're looking at, trying to solve. Taken R times, so I have a group of 50, I'm taking R of them, whatever that number happens to be, where order is not important. So that means it doesn't matter if you choose somebody first, second, third, fourth, or fifth. You're just taking a group of objects, a group of items, whatever you're dealing with. And we're not worried about which one you choose first versus which one you choose last. Or if I'm taking 2, I'm taking a pair of something. So the difference would be that order would not be important. So if you see that something has to be in first, second, or third place, that's a permutation. If we're not talking about a position that something is happening, then it's a combination. There is a little formula that goes along with a permutation and a combination. So yesterday we did the permutation formula. That's the formula that's already programmed in your calculator. So right here's a permutation formula. The combination formula has one extra part. So besides taking n minus r factorial in the denominator, it's also being multiplied by r factorial. Again, you don't need to know that unless you don't have a graphing calculator that has the options for you to do the permutation and the combination. If you do have a calculator, then you're hitting the math button. You're going over to the probability option, and this time it's number 3. So permutation is number 2, factorial is number 4, and combination would be number 3. And it really does matter like which one you choose because it's a different formula that's programmed into the calculator. So the first problem here, this one's pretty straightforward. You are picking 7 books from a stack of 32. So you have 32 books in a stack, you want to pick 7 of them. If the order of the books you choose is not important, how many different book groups are possible? And that word groups is one of the key words to look at if you're deciding whether it's a permutation or a combination. So we have 32 books. We're picking groups of 7 books. How many different ways can we take 7 books of those 32? Eden? 960? 860? 856. And then we'll say groups, because that was what it was asking for. So 3,365,856 different groups of 7 books, which is still a lot of options. So that is just a basic combination. So set it up. How many total? What are we pulling from that total? It's a combination. Order is not important. The next page is talking about doing multiple events. So not only would I be picking a stack of 7 books, but maybe I wanted to choose 5 books to be romance and 2 of those books to be like action or fiction, whatever you want to say, action books or sci-fi book or something like that. So it gets more specific based off of the type of books that you want to choose from. There are 2 different types of ways or words that you're going to be looking for when you're looking at multiple events. So this is like this event happening and this event happening and this other event happening. And the word and would be the first word that you're looking for. So when finding the number of ways that both event A and event B can occur, we multiply the combinations together. So you're going to multiply the values that you get from the combinations together. And again, the reason we're doing this is because you're going to have like 2 things that you're trying to find. And when it's the word and, we multiply. So we'll be applying this next week to probability as well. When we see the word and with probability, we're also multiplying. So 2 things occurring at the same time. The other option would be if one event or the other one can happen. So you either have one thing occurring or the other. It's going to rain or it's going to snow. So when that happens, we add the combinations values together. And again, next week on Monday, we'll be looking at probability of 2 events, either one thing happening or the other thing happening, and we'll be adding their probabilities together. So they kind of go hand in hand. So in this case, looking at the next example, the reason this changes is because now the question is a little more specific and we have different options to choose from. So you are going to the Redbox, since I don't really think there are any local movie rental stores that are existing. But you go to Redbox or you go to Netflix, wherever you want to go. The store, so you got some kind of special on new releases. The new release consists of 12 comedies, 8 drama, 8 action, 7 drama, 5 suspense, and 9 family movies. So those are all the new releases that maybe were put into the Redbox for the week. For part A, it says you want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? So you're going to go to the movie store or the Redbox or Netflix, wherever it happens to be on demand. But you want to get exactly 2 comedies and 3 family movies. So the word and tells us we have to multiply. You need to do each piece separately. So think about doing the comedies first and calculating a value, and then also doing the family movies and calculating a value. So how would we calculate the number of options we have when we're dealing with the comedy movies? Aaron?
Do 12 in CR2.
And why are you choosing 12? Right, there's 12 comedy movies to choose from. So we can't use 41 because 41 are all of the options. We specifically only want the comedies. So we have 12 comedy movies to choose from. Of those 12, we want to pick 2 of them. And then Aaron, the family movies would be?
9.
Right. So I would like to see the numbers you're getting for both of them. So if you calculate the combination for the comedy movies, what number is that when we have 12 movies to choose from and we're picking 2 of them? Virginia?
66.
66? And then for the family movies, we have 9 family movies to choose from, and we're picking 3 of them. Caitlin, what number is that? 84. So if we multiply those 2 together, Caitlin, how many different movie combinations could we rent?
5,544.
So we'll say movie combos. So because we're doing both, we want both of them to happen, we multiply those values together.
It's 5,544.
44? My hearing isn't working today, I guess. Alright, so looking at the next question, it says you can afford at most 2 movies. It doesn't specify which kinds, but you have enough money to rent 2 movies. How many movie combinations can you rent? So how would we set that up? Mason?
41. C2.
So he said 41C2. So this is renting 2 movies. What does the word at most mean?
No more than.
No more than. So is there another option that you could have?
Could we do 41C1?
So you could do 41C1. Because maybe you don't want another movie, you only like one of the options you have to choose from.
We get no movie?
You could also get no movies because you didn't like any of them. So at most means I need at least 2 movies, but I don't, or at most 2 movies, but I don't need to choose all of them. I could only have one option that I like, or maybe I went there, I looked at it, and then I didn't have any options. Do we add or multiply these together? Paige? Add. Because I could rent 2 movies, or we could rent 1, or we maybe didn't want to rent any of them. So you want to add those options together. So when you see the word at most, it means that there are other options that you need to think about as well. So what number do we get for 41C2? Caitlin? 820. 41C1 is just 41, and then 41C0 is 1. Because there's that one time that you could go and be like, you know what, forget it, I don't want to see or get any movies. So when we add all those together, we get 862 movie combos. Any questions on either of those 2? So I believe underneath, just really quick little problems underneath, working with plugging in the combinations. So find 7C4, 6C3, 12C11. And then for part 4, going back to the movie question, find the number of movies that are possible if you choose 2 action and 2 drama. So just plugging these into your calculator. These would be no work. You already have, there's not a word problem you're solving for. Just plugging into the calculator. Sam, what did you get for 1, 2, and 3?
35, 20, 35, 20, and 20.
And then for number 4, Sarah, how do we set up number 4?
It would be 8C2 times 7C2. Which
And those two numbers are,
28 plus 29,
which is?
588.
Does anybody have questions on doing multiple events with the combinations? So the last thing that we are going to look at is combining the two together. Is it a permutation or is it a combination? Just looking at 6 different word problems, deciding which one of those it applies to. Because it's not always a combination and it's not always a permutation, so you have to decide which one to use. So for A, 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. How many different ways can the bobsledding teams finish the competition? Virginia, what do you think? Permutation or combination? Why?
Because it's about order.
So it is about order because it's talking about them finishing the competition. And anytime it uses the word finish or placing them in arrangement, 1st, 2nd, 3rd, 4th place, it is a permutation. And I'm going to abbreviate instead of writing out the whole word. So Virginia, what would this look like then?
You do 10 P, and then it would just be, wait, it would just be 10 factorial.
Yeah, it's just 10 factorial. So if you have a case where you're saying 10P10, there's 10 teams, all 10 of them need to finish the competition, that's really just taking 10 factorial. So when all the teams are finishing in some place, 1st through 10th place, then it's 10 factorial. And Virginia, that number is?
3,628,800.
B says a standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. How many different 5-card hands are possible? Is that a permutation or a combination? Paige, what do you think?
Combination.
Yeah, this one is a combination. We're just dealing with 5-card hands. It's not saying I have to pick something first, like an ace first and then a queen second. So it's just 5-card hands. And Paige, how would that be set up with a combination?
52C5.
52, we're picking 5 cards. Out of those 52,
25,986. Oh, I did that wrong. 2,598,960.
letter C, for summer reading, you're asked to read 2 books from a list of 6. How many different pairs of books can you choose to read? Sam, what do you think?
Is this a combination?
It is.
So it would be 6 C2.
Good.
And then the answer would be 15.
15?
Yeah.
So 15 different pairs of books. Ethan.
Is it
There's
typo?
a typo.
It says form a list. 2 books form a list.
What?
Oh,
Where?
from. Oh.
There's also a typo earlier, right?
Oh, well, thanks. I appreciate it. But I can fix it for next year if I know. I have to make sure I fix that. Gotta write myself a note. Where was it earlier, Sam? Today?
No, it was yesterday.
Oh.
Remember a year later, just write it like
Yeah.
which forms are from both.
Sam, if you find it, let me know, okay?
Okay.
Letter D. 12 students enter a talent show. Awards are given 1st through 5th place. How many different students can finish, or how many ways can the students finish 1st through 5th place? Kate, what do you think?
Is it a permutation?
Why?
Because it's finished, like it's a place.
Correct. So it talks about finishing first through fifth place. And if we're finishing first through fifth place, then it is a permutation. So Kate, how many people are in the competition?
12.
12. And we're picking how many places?
5.
5. Yep. So it'll be 12P5. And then that number is?
95,040.
So 95,040 different ways that people could finish first through fifth place if there are 12 people in the competition. Letter E, a 9-person baseball team is about to play. How many ways can you list the first 6 players on the batting order? Anthony, is this a permutation or a combination? Because? He says, why is she calling on me? So you're right. Why is it a permutation? What word is in there? Ethan, you want to help him out? List? What other word is in there?
How?
Order.
What? That's not order. That's not permutation.
Yeah, that is.
So the word order, a batting order, there's a specific way that you have to bat first, second, third, fourth, fifth, sixth, seventh, eighth, ninth place, or ninth position in the batting order. So 9-person baseball team, we want to list the first 6 players. What is 9P6? H?
60,480.
And then the last one, 10-person basketball team. How many ways can you select 4 players to take part in the pregame coin toss? Permutation, combination. Aaron? This is just a combination. We're not talking about them like starting first, second, third, fourth. So 10C4, Aaron gives us 210.